Any other question you want me to go over? Any other question you want me to go over? Yes?
Can you go over 5A?
5A. 5,
You said 8.
8.
5A.
No one square root x over y.
Square root x over y.
Oh wait, no.
Equals to one.
Equals.
So this one is gonna be x to the 1/2 equal to y. It's an exponent, so you start with the base. So be log of x of y is equal to 1/2. Yeah.
Is there any other square root for it?
Yeah.
Any other question? And for this one, you need to change to like says 3 to the 3, because that's equal to 27. Then you can say log 3 of 27 is equal to 3. Any other question you want me to go over? No? Okay. We are gonna talk about properties. So let's talk about how do you find inverse of a logarithm graph? Okay. Or inverse of this. So this is a very, very good question. So your homework question is gonna have this. We're gonna talk about inverse. We're gonna talk about graphing. We're gonna talk about all the things. So let's start by talking about inverse. Now, what if you have y equal to log 2? Log 2 of x plus 8 minus 2. So let's say, hey, how do I find the inverse functions? How do I find the inverse function? What do we know about inverse from before? Switching x and y. So be x equal to log 2 of y plus 8 minus 2. Is that okay? Now the goal is to get this y by itself. Do you know how to get y by itself? What do you have to do first? Plus 2. Why do I plus 2? Because I need to isolate that log 2 of y plus 8 first. Is that okay? So be x plus 2 equal to log 2 of y plus 8. Now, there's two ways to approach this. One is using the property. One is changing the exponent form. Either way, it's fine. So I'm going to use a property first. If I confuse you, you can use it the other way. So the property is basically, how do you get rid of log 2? According to property, if you have b to the log b of x, that's equal to x, because b and log b, they're inverse to each other. They can cancel out. So what we can do is 2 to the x plus 2 here. We can raise the power. And I have 2 log 2 of y plus 8. These two things cancel out. So be 2 to the x plus 2 equal to y plus 8. And then y equal to 2 to the x plus 2 minus 8. And this is the inverse. Or you can say it's f inverse of x is equal to 2 to the x plus 2 minus 8. So the inverse function of this is this. Now you're gonna be like, I don't know. I think Olivia look at this like, what the hell is this? Well, fine. You can do it this way too. You can start from the base, sideway heart, right? Hold on a second. Sideway heart. So like this, right? So it'll be 2 to the x plus 2 equal to y plus 8. Can you do that? Change it to exponential form and move the 8 over. And you're gonna get the same thing regardless of different. So you can use the heart thing to get the same answer. Some people prefer to do this way because this makes the sense to them. But I will want you to make sure that you can understand the property here. One more things. How do I know those two are inverse to each other? How do I verify they are inverse to each other? So this is what is. If f of x and g of x are inverse, then the following must be true. Now this one is kind of take a little bit understanding. So that means f of g of x is equal to x, or g of f of x is equal to x. If they are composite to each other, they should cancel out. For example, one of the easiest one you know is y equal to x squared and y equal to square root x. They are inverse to each other, right? So if I plug this in here, let's just say one of them is f of x, one of them is g of x, and if I plug this in here, so f of g of x, that's equal to square root x square, that's equal to x. So they are inverse to each other. You verify that's inverse. So I'm going to do the same thing on here. So we have f of x is equal to log 2 of x plus 8 minus 2. And g of x is equal to 2 to the x plus 2 minus 8. So if I put this in here, if I take this and I put it here, hopefully you're going to get x. So f of g of x is equal to log 2 of 2 to the x plus 2 minus 8 plus 8 minus 2. That's equal to log 2 of 2 to the x plus 2 minus 2. Does that make sense? This 2 inverse to each other, they cancel out. So it'll be x plus 2 minus 2. So that's equal to x. So if it's equal to x, you just prove this is inverse to this. This is to inverse of this. You can verify by plugging this into the other function. The inverse function into the f of x. If it comes back to x, then you know they are inverse. So I'm going to give you a question. And let's see if you can find the inverse of it, okay? Yes. This part?
Like that whole section, I think.
Which section?
Yeah.
Sorry, I'm trying to make it bigger. Okay, so today, I says, hey, can you find out 3 to the x minus 1 plus 2? I says, hey, can you find the inverse of this function? Let's try it. We go the other way now. We're going backwards. And you can verify by plug in, see if it's true. If we come out x. Then you're done.
I think so.
If you're playing Brawl Star, I have to throw that phone out the window.
I don't.
Ask Bennett. I throw his phone out the window a couple times. Wait, do you know Bennett? No. Bennett Gordon. The last time I threw a phone out the window. I also threw Ethan phone, Palm's phone out the window. Right now, you done? It's easy. It's easy. Apple, you done? Emma, you done? Now, I'm gonna find an inverse. First thing, I switch. I say, and I know this is f of x. F of x equal to 3 to the x minus 1 plus 2. I'm gonna switch x equal to 3 y minus 1 plus 2. Is that okay? I move 2 to the other side, so x minus 2 equal to 3 to the y minus 1. Is that right? Now, I'm gonna do the other way first. How do I get rid of 3? I need to do this one. So there was 2 ways to do it. B log of b of x, that's equal to x, because this will cancel each other out. Or log of b to the b like this, that's equal to 1. So therefore, I'm going to get rid of 3. I need to do log base of 3 of x minus 2 equal to log 3 of 3 to the y minus 1. So this will cancel out. This means y minus 1 equal to log 3 of x minus 2. And then y is equal to log 3 of x minus 2 plus 1. Do you guys get that? Or f inverse of x equal to log 3 of x minus 2 plus 1. Is this okay? Yes.
If I just did like the heart thing.
You can do the hard thing if it makes easier for you. It doesn't matter. Math, it doesn't really matter. Because if you do it this way, so it's going to be 3 to the y minus 1 equal to x minus 2. So, oh, sorry, it's the other way. I should do it here, right? So it'd be log 3 of x minus 2 is equal to y minus 1. So y equal to log 3 of x minus 2 plus 1. Now I want to talk about one more thing. I gotta be able to see if they're inverse to each other by plugging this into here. Does that make sense? If you want to verify. If you want to verify, then that's going to be f of g of x. So that's going to be 3 to the log 3 x minus 2 plus 1 plus 2. So that is going to be cancel out. That's going to be x minus 2 plus 1 plus 2. Wait, I messed up something. What did I, oh, this is minus 1, right? Wait, hold on a second. Huh? This one is minus 2 or minus 1?
You plug in y and then you do the minus 1.
Hold on, I'm confused now. So let me try to do it again. So it'll be 3 to the log 3 of x minus 2 plus 1 minus 1 plus 2, right?
Yeah.
So this cancel out. So that's equal to x minus 2 plus 1 minus 1 plus 2. So this cancel out. That's equal to x. So we have just proved that they are inverse each other. Uh-huh. I plug in this whole thing into here. So then that is going to be log 3 over x squared plus 1 minus 1 on the back. Because there's a minus 1 after and plus 2. So this will end up eventually cancel everything out. They're inverse.
One more question at the end. Hang on back. I think it's comprehend it. Comprehend it now.
You just adding ing on Spanish words?
Yeah. Oh yeah.
Oh, is that what you did?
Yeah, that's what it is.
Okay, but let me finish this. Yes, Denisha?
The property,
Which property?
the one you use, I don't understand how to cancel.
Oh, you don't know how to cancel out. So if you have a 3, right? It's to the power like this, and you want to cancel the space, the only way is you can do log 3 and log 3 on both sides. And this one's going to be 3 to the y minus 1. So this will cancel out. And or you can do the hard thing. So the hard thing is easier. So you can straight go through here because it's going to be log 3 base of the other side equal to this side. And move the 1 over, you solved it. Now what happened is this. You can actually learn how to graph logarithm. So I'm going to teach you how to graph logarithm. Okay, so just like any type of y equal to 2 to the x, y equal to 3 to the x, y equal to 5 to the x, they all have a similar graph. And the graph is going to be like going through here, like it's all have this, and they all have same thing. They all have similar things. It's just one graph maybe a little bit steeper than the other one. And the other graph is probably a little bit not as steep. So it's probably like there's another graph that's gonna go like this. So there's probably 3 different graphs. But for us, everything, they all have a same anchor point and same asymptote. Now, same thing about log of x. So y equal to log b of x, same thing. So imagine if you have 2 to the x. So 2 to the x is going to be right here, right here, right here, right here. It's like this, right? So they have an asymptote like right here. So this is y equal to log 2 of x. I mean, sorry, 2 to the x. 2 to the x, okay? Log 2 of x is basically this asymptote is right here. And it's going to go do this way. So this way. And this is log 2 of x. So they have anchor point here at 1, 0, and it's going to move. So if today I say my function is log 3 of x minus 2 plus 1. So let's copy this here. Let's copy this. Copy, paste here. And that's copy this. Copy and paste here. So one is a blue, one is red. So let's graph the blue one. The blue one is the one that you need to learn how to graph today. We know the asymptote start here, right? So it's moving what? Right or left? Right, good job. It's going to be right too. So the asymptote is going to be like this. The anchor point star at here is moving right 2 and up 1. So it's going to be like this. So this point here is moved right 2 and up 1. Is that okay? And the graph's going to be like this. That's it. And that's the anchor point and the asymptote. Now let's graph the red one. The red one says the asymptote used to be right here, right? It's going to go up 2. So it's going to go up 2. So the asymptote is right here. The anchor point is start right here. It's going to go right 1, up 2. So it's going to be right here. And if you realize that this is exactly the symmetry is, and you see that this graph, it's going like this. But this has a horizontal asymptote rather than vertical asymptote. The other one is they are inverse, so they switch from horizontal to vertical. Yes.
And the 3x, the red one more time.
Sure. It used to be right here, right? This asymptote is going to go up by from here to here, right? The anchor point is going to go right 1 and up 2 because this is right 1 and up 2. So it's going to go here. So the asymptote is right here. So the graph is going to be like this. And same thing of this one is just going to be this way because we start with here. Then move right 2 and up 1. And the asymptote move to here. you basically move according to it, and you're gonna see the same asymptote as well. So you gotta be able to graph this. So Diego says that he needed one more question. So that's fine. I'll give you one more question. Yes.
How do you graph the inverse one?
Which one?
Or any of them?
For this one?
Yeah.
Okay. So for this one, you don't really matter. It just pretty much this point is gonna move right 2 and up 1. So that's how you get from here to here. And you have an asymptote right there. So basically this is the graph, this is the graph, and they have a still symmetry. And they are still y equal to x, y equal to negative x, y equal to x is the symmetry line. It doesn't matter they are natural log or log. It's not base 10. This asymptote right here. Now, if I have natural log of x minus 3, if I have natural log of x minus 3, so that means move which way? Now this anchor point is going to move right 3. Now this anchor point is going to move right 3 and up 4. So the graph is going to be this, with the anchor point like this way. Now how much it curve? I don't know. Like this way. Now how much it curve? I don't know. I can't really use restrict. I can't really use restrict, right? When somebody graph like this, I'm okay with that, right? When somebody graph like this, I'm okay with that because long as minus of x. Verify f inverse of x by plug-in. It's composite of this cheddar. Is verify f inverse of x by plug-in. It's composite of this cheddar is equal to x. Then you verify it. Okay, so we're gonna do kind of quickly. So first of all, we're gonna graph. We're gonna graph 3 to the right. This one's y. Sorry, this is y. So y minus 3. Is that okay? I can do 5 to the x minus 1.